Okay, so what you see before you is a keyboard attached to something called an oscilloscope. And what the oscilloscope will do, it's going to read the sound waves of the keyboard and it's going to display the wave in this blue box at the top. Okay, so the first characteristic that we're going to look at is the characteristic of amplitude. And amplitude is how high the wave goes and how deep the wave will go. So it will be, the amplitude is how tall it is and how deep it is. And the amplitude is going to give you an idea of the loudness or the intensity of the sound. So right now we're going to turn the volume way down. All right, so it's going to be a very soft sound, and so it's going to have a low amplitude. All right, they're short. It's not very tall. It's not very deep. They're just short, shallow waves. Okay, now if I increase the volume, so it's going to be a lot louder, and so the waves are going to be a lot taller and a lot deeper. All right, so the waves are much bigger there. So loud has a large amplitude and soft has a low amplitude. Okay, easy enough, right? The next part is going to be frequency, and the frequency is going to be associated with wavelength. Now this is the wavelength. Now we can measure wavelength in a couple of different ways. A wavelength, a full wave, is basically a full top part and a full bottom part, a full hill and a full valley. So we can measure the wave. We can measure this wave from the two troughs. That's the most deepest part, right? We can go from trough to trough. We can measure from crest to crest, right? So this would be a wavelength and this would be a wavelength. Or you could measure it from the beginning of a valley to the end of a hill. So this would also be a wavelength. And all of these are the same size. Okay? Now, when we look at, let me move this out of the way, clean that up. So when we look at the frequency means how many waves there are going to be per second. So if we have a very high pitch, a high sounding pitch, like a screech, the waves are going to be really short and there's going to be a lot of them. Okay, so there's a lot of waves, and so there's a lot of waves per second, so it's a high frequency. If you look at the number here, you can see that the number is measured in hertz, Hz, and at this one we have 784 waves per second. Okay, now if it's a low sounding tone, then the waves are going to be stretched out. They're going to be really spread out. Let's do something in between here. So here's a high frequency. Here's a medium frequency. All right, and you can hear the difference there, right? And here's a low frequency. All right, so that's really low. I think this one's so low you can't hear it at all. Yeah, that one's so low you can't even hear it. So let's do that one. So there's a low frequency with long wavelengths. Medium frequency with medium wavelengths. And a high frequency with really short wavelengths. All right. Hope that gives you a good idea of how to read a sound wave.